Lesson 39 has three parts. The first part is about the trichotomy axiom. The second part is about negated inequalities. And the third part is about advanced ratio problems. Now, the trichotomy axiom. It sounds complicated, trichotomy, but tri just means three. And if we look at the definition for the trichotomy axiom, it's really not that complex. We can draw pictures. The first one says the second number is less than the first number. Well, that's one possibility if we're comparing two numbers. So let's say the second number is 4. The first number, if the second number is less than the first number, 4 must be less than, maybe 5 is the first number. The second one says the second number is the same as the first number. Well, maybe the second number is 4 and the first number is 4. Well, when we compare two numbers, they can be equal to each other. And the third part of the trichotomy axiom says the second number is greater than the first number. So maybe the second number this time is 5. And it's greater than a number like 4. We can always compare two numbers. One's going to be less than the other, one's going to be equal to another, or one can be greater to another. Those are our only three choices. Please make sure you write the trichotomy axiom in your notes. Pause the video now if you need to. Now, as you wrote this in your notes, did you see how I changed up the way I wrote this? The first one I wrote all out in words. The second one I used some words and I used some symbols. And the third one I used as many symbols as possible. We could have even made a greater than symbol here. I would encourage you in your notes to use as many symbols or abbreviations as you can. It makes it a little bit faster to write out your notes, and it means the exact same thing. Let's move on to negated inequalities. Negated inequalities just means the opposite of what we're given. So, the negative of what we see, the inverse of what we see. So draw a number line and graph the solution of x is not less than 2. Okay, if x is not less than 2, what that means is we want the opposite of that. So we want x to be greater than. If it's not less than 2, it needs to be greater than or equal to 2. So we're going to take completely the opposite inequality sign that we see and then graph it. So x is greater than or equal to 2. It's greater than or equal to 2. We must have to have a closed circle on 2. Then we have x is greater than or equal to it. It's bigger than it, so we must be going to the right. And we've got our final answer. That's all we do with negated inequalities. Just find out what the complete opposite inequality would be, and then graph it on a number line. The third part of our lesson is about advanced ratio problems. Let's read this one. The ratio of red marbles to blue marbles is 5 to 7. If there are 156 marbles in the bag, how many marbles are red? Now this question is tricky. Watch. It says the ratio of red marbles, red, to blue is equal to 5 to 7. That's pretty straightforward. Now it says there are 156 marbles in the bag. Well, if there's 156 marbles in the bag, that must include the red marbles and the blue marbles put together. What we want to know is, given that there are 156 marbles in the bag, how many marbles are red? So what we really want in this problem is we don't want to know the ratio of red to blue. We want to know the ratio of red to total, because that's what we're given for our information. There are 156 total marbles in the bag. So 156 total marbles in the bag. How many are red? Well, we don't know. We'll call that x. Let's circle it so we know that's what we're solving for. In order to write a proportion for this, we don't need the 5 to 7. We don't need red to blue. What we need is red to total, because we have 5 red for every 12 total marbles. And we know there's 12 total marbles for every 5 red, because 5 plus 7 is 12. So when we get this part, red to total, now we can go ahead and solve. We can say 5 over 12 is going to be equal to x over 156. We can use our proportions to solve. We're going to multiply 5 times 156, and that's going to have to be equal to 12 times x. Let's go ahead and draw a vertical line here to box this section of our page off. That's going to give us our answer. We've got a lot of side work so far. Let's do 5 times 156 up on top. 5 times 6 is 30. We're going to carry the 3. 5 times 5 is 25, plus 3 more gives us 28. We're going to carry the 2. 5 times 1 is 5, plus 2 more is 7. We get 780. So, 780 must be equal to 12x. We want to figure out what x is, so we're going to undo the multiplication of 12 by dividing by 12. Then we're going to divide 780 by 12, and we can figure out our answer. I'm going to erase some of our original work. Let's erase over here. We didn't need that anyway. So, we have 780 divided by 12, 780 divided by 12. Well, 12 is going to go into 78 6 times. 12 times 6, what's 12 times 6? 12 times 6, that must be 72. We're going to subtract. We have 6 left over. Bring down our 0. We have 60. And 12 goes into 60 5 times. We have nothing left over. We've got our answer. In this, 780 over 12, that's equal to 65. So 65 is equal to x. And in this problem, it said how many marbles are red? Well, 65 marbles are red. So let's write out a label, 65 marbles. And we've got our answer. We're all done with this advanced ratio problem. Lesson practice will be on page 158 and 159. Make sure you've got your notes completed. Write down any questions that you may have, and I'll see you during our next class.